Welcome to the video for the model question for C2.3.3. So this is asking us to explain the differences in melting points for three different substances. So first thing we need to do is realise that the melting point is determined by, so it depends on the strength of the forces of attraction that need to be broken. So we need to look at the strength of the forces of attraction in each of these substances and compare them. So it depends on the strength of attraction. So we need to look at each of these substances in terms. So sodium chloride, so sodium is a metal and chlorine is a non-metal. And because you've got a metal that's reactive with a non-metal, that means this substance is ionic. And ionic substances have high melting points because you've got strong electrostatic forces of attraction between the opposite ions. Water is, so water's H2O. So both hydrogen and oxygen are non-metals. So this is covalent and it's simple covalent, which means you've got small molecules and you've got weak forces between them, which is why we've got a relatively low melting point here. And then diamond is an allotrope of carbon. So it's just carbon. So again, it's covalent. But if you look at the two melting points here, so the melting point for water is a lot lower than it is for diamond because although it's covalent diamond, it's giant covalent. And therefore you've got strong forces of attraction because you've got many strong covalent bonds that need to be broken. So I'm now, that's all we need to consider. So I just need to write this in. Remember, it's quality of written communication is important in these questions. So I need to write in full sentences. So I'm going to start with sodium chloride. So sodium chloride has a high melting point this is because, so we need to say why in terms of the forces of attraction. So this is because it is an ionic compound. Therefore, there are strong forces of attraction. And I need to say what these forces of attraction are between. So in an ionic compound, it's between the positive and the negative ions. So therefore, there are strong forces of attraction between the positive ions and the negative ions. And because we've got a strong attraction, you're going to need to put lots of heat energy in to overcome. So this takes a lot of energy, so a lot of heat energy to overcome. Right, so that's the first one. So then water. So water is a simple covalent molecule. So people quite often get mixed up here because covalent bonds are strong, but when we're melting water, so which we normally call ice. So if I've got ice and I'm melting that, I'm not breaking the covalent bonds. What I'm doing is I'm overcoming the weak forces between the molecules. So when it melts, the strong covalent bonds are not broken. Instead, it is the weak intermolecular forces. So that's just the forces between the molecules. So the weak intermolecular forces that need to be overcome. Therefore, this doesn't require much heat energy. So the melting point is low. Right, and then diamond is a giant covalent structure. Okay, so what that means is that when you're melting that, every single covalent bond needs to be broken. So each carbon has 4 covalent bonds that need to be broken. Okay, so this means that many strong covalent bonds need to be broken. This takes a lot of heat energy. So the melting point is very high. Okay, so let's go back to the question and check that I've done everything. So it says, just explain these results by referring to the structure. So I've talked about the structure of each of those, and I've linked it to the forces of attraction between all of them, and linked that to the melting point. Okay. So now that you've seen the approach to this question, it's your turn to have a go at this question. So this question's asking, so it's similar in that it's got 4 different substances, but it's asking you, instead of melting point, to think about whether they conduct electricity or not. So again, you need to look at the structures of the substances. So you need to identify the structure of each of these and link that to whether it conducts electricity or not. And the thing that you need to think about is that whether a substance conducts electricity or not depends on, are there mobile charged particles? And if there are, then it will conduct electricity. And if there isn't, then it won't. Okay, thank you for listening. See you next time.